Okay, so we'll do this together now. Okay, so again, we're trying to find a quadratic function, right, whose vertex is this point and it passes through another point. You know, that's what we want to do. So for the first one, right, we want a quadratic function whose vertex is -1, 3, and it also has to pass through the point 3, 5. Okay, so that's what it also has to do. Okay. Good. So again, we have our quadratic function here, as you can see. You know, we have a times x minus h squared plus k. So here we're saying that the vertex, which is hk, has to be this point, -1, 3. Right? So again, when 2 points are the same, right? When 2 points are the same, the x coordinates are equal, right? H is equal to -1 in this case. The y coordinates are equal, so k is equal to 3. So if we plug that in, we get f of x is going to look like a times x minus -1 squared plus 3. Right? And of course, that's the same thing as saying this. A times x plus 1 squared plus 3. Okay? So right now, so basically we got a lot of it done. We know what h and k are. We're not quite done yet because we have to figure out what a is. Now, how do we do that? Well, remember, you know, if you're given something, you have to, odds are you're going to have to use it, right? We know it passes through the point, 3, 5. So what does that mean if it passes through the point 3, 5? When f of 3 is 5. In other words, when x is 3, we have to get 5. So in other words, we have this equation here, which is, and if you simplify the right-hand side, you get this. A times 4 squared plus 3, which is 16 times a plus 3, as you can see. So this is what we get. But again, we have to figure out what a is. That's our unknown, so we solve for it. We have 16a plus 3 equals 5, right? You know, I interchange both sides of the equation. That's what I did. 16a plus 3 is 5. Next, we want to get a, so let's subtract 3 from both sides. Again, we want to get a all alone. We have 16a equals 2. Okay, so I just brought the 16a closer. Then we divide by 16, right? Because we want to get a. You know, 16 is being multiplied to a. How would we get it off? Divide. So we divide both sides by 16. So we get a is 2 over 16. For some reason, I forgot to put divided by 16 in the slide, so I wrote it here for my other class. But anyway, we get a is equal to 2 over 16, which is 1 over 8. So when we put it in, we have our function, which looks like this. All right. So from here, again, you can always graph like I did here to just double check, and that's what I did. All right, you can see if the vertex is 1, 3. No, excuse me, -1, 3. And it passes through the point 3, 5. That's what we're looking for. Okay, so that one was good. Any questions on that? Okay, so for this one, it's the same idea, right? You know, we know the vertex, we have a point that's on the graph. Let's find an equation for that. So we have f of x, oh, excuse me, you know, this is our standard form, as you can see. hk, we have, right? We have hk is 4, -2, right? Again, the vertex is hk, and here it's 4, -2, so hk has to equal to 4, -2. So what do? H is equal to 4, k is equal to -2, as you can see. Right? When 2 points are equal, the x coordinates must equal each other. So h must equal 4, and k must equal to -2, as you can see. Okay, so from here, we can plug in h and k, and we have this so far. But again, we need to know a. How do we get a? We know it passes through the point 1, 7. So that means f of 1 must be 7. So f of 1 must be 7. In other words, when x is 1, this expression must equal to 7. That's what we're using here. So when x is 1, the whole thing is 7. Now we can simplify the right-hand side a bit, right? We get a times -3 squared minus 2, which is equal to this. Which is equal to this. Okay? So in other words, we have 9a minus 2 is 7. Okay? Good. So from here, we get 7 is 9a minus 2. Again, we want to figure out what a is. So what do? We solve for a. So I interchange both sides to keep the unknown on the left side. Okay? So we have 9a minus 2 equals 7. Okay, that's good. So what do we do next? We add 2 to both sides, right? Because again, we want to get a all alone. So we have 9a equals 9, like so. But hopefully now you can probably see what the answer is, even without this down here. But it's good to solve for it. Divide both sides by 9, right? You want to get the 9 out of there. We get a equals 9 over 9, which is 1. So all together, we get this. F of x is equal to, I mean, the 1 you don't write. If you did write it, you're not going to lose points with me. So you get f of x is x minus 4 squared minus 2. Okay? So that's what we get there. And as a check, we can graph it, and you can see, yeah, the vertex is in fact 4, -2, and it passes through the point 1, 7. So we're good. All right. All right. Any questions on that? All right. Okay, so now I want to start the new stuff, which is chapter 3, but now we're going to look at section 3. So let me get that up. Hey, oh boy. Oh, there it is. There we go. Here it is. Here it is. All right. So here, again, if you can't see the notes, just, speak up, or if you can't hear me. So here what we're going to look at is dividing polynomials, right? We saw addition, subtraction, multiplication. So it's only natural that we consider division. And there is a division algorithm for polynomials. There is one also for integers as well. Namely, if you have a polynomial f of x, right? Let's say that's being divided by the non-zero polynomial d of x. It's being divided by that, okay? It turns out once you have that, there are two unique polynomials, q of x and r of x, such that this is true. F of x over d of x can be written as q of x plus r of x over d of x. Again, q and r are unique, where you can do this. And from here, this is equivalent to writing this. So that's what we get here. Right. And also r of x, I forgot to say it even though it's right here. R of x, is either the zero polynomial, meaning it's identically zero. For every x, you get 0. Or the degree of r is less than the degree of d of x. And the notation really gives it's supposed to help you with the names, like what they're called. Capital F of x is the dividend. Okay? Capital D of x is the divisor. Capital Q of x is the quotient. Capital R of x is the remainder. Just like, when you're dividing numbers, right? You get a quotient, a remainder, all that stuff.